Hi y'all, it's me, Miss V, and welcome back to another video. And today what we are going to be talking about is the properties of dilation. So in my last two videos, I went ahead and I discussed what dilations were and what happens when you dilate from a point other than the origin. And today we're going to be talking about some basic properties of dilation. So for example, the most common thing that we know in dilations is that the angle measurements of both figures are going to stay the same, okay? So angle measurements are preserved. So for example, if I have a triangle, and let's say this is my triangle ABC, okay, ABC, and let's say the measurement of C is 70, B is 50, and let's see, 70 plus 50 is 120. So this would have to be 60. Okay. All right. So yeah. Sorry, I was adding up to three angles because we know the three angles in a triangle always add up to 180. So now let's say I decide to dilate that triangle. So dilate triangle ABC by scale factor of 1/2 or 1/3, whatever. It doesn't matter. Oops. So it's going to be half the size of the original triangle. Okay, so notice the side lengths are not going to be the same anymore. So let's say if AB was 12, now A prime, B prime is 6, CB was 8. So now C prime, B prime is 4. And let's say that AC was 10. Now A prime, C prime is 5. So each of the side lengths shrank by a half, or were dilated by a half. But the angle measurements actually will not change, okay? So A prime will still be 60, B prime will still be 50, and C prime will still be 70. Because at the end of the day, you still have a triangle, and the angle measurements aren't being affected by the scale factor. Because think about it. The three angles in a triangle always have to add up to 180. So let's say if I were to say, oh, well, since I dilated it, maybe that means that the angles are going to be multiplied by half. So now you'd end up with a triangle that has 30 degrees, 25 degrees, and 35 degrees as the angle measurements if you multiply 60 by a half, 50 by a half, and 70 by a half. But now if you add those three together, that's definitely not going to equal 180. So now you don't have a triangle anymore. Okay. So remember, whenever we do a dilation, we still have the same exact shape. The only thing that happens is that the size of the shape changes. Okay. So we'll still have a triangle, still has to follow all the rules of a triangle. The only thing is now it's a smaller triangle or a bigger one. Okay. So the second property of dilations is that let's say you're dilating a line. Okay. So let's say we have this line here, PQ, and this line over here, LN, okay? So let's say you want to dilate, okay, line PQ by a scale factor of, let's see, dilate PQ by a scale factor of 1/3, okay? And let's say that you want to leave, we'll leave that as line N. So let's say that line N will be, point N is your center of dilation, okay? So now in an example like so, what you're basically doing is this line PQ, you're dilating it by a scale factor of 1/3. Since 1/3 is smaller than 1, it's going to shrink, okay? And since you're using N as the center of dilation, then essentially what you're doing is N is in the middle. Okay, so now the distance from, remember, whenever we're looking at a different point other than the origin, you measure the distance from that point to one of the coordinates of your shape or line in this case. Okay, and now whatever that distance is, so like let's say this distance here from P to N is 6. Okay. Now for your new shape, since you're dilating it by a scale factor of 1/3, okay, your new shape is going to be, the distance is going to be, instead of 6, it's going to be 6 divided by 3, which is 2. So now P prime, let's say, is over here, okay? So this distance here is now 2, okay? Same thing with NQ. Let's say NQ, the distance from N to Q is 3. So now the distance from N to Q prime is going to be 1 instead, okay? But notice P prime, Q prime, that little green line right here, is still on top of that original line PQ, okay? So it's still on top of that line. Now it's just a third of the size of that segment there, okay? So essentially, whenever you're dilating lines, you just have to be very cautious about what the center of dilation is in terms of which point they're using. And you also have to be cautious of which line are you dilating specifically and by which point, okay? So like some properties that you would notice here is that PQ is greater than P prime Q prime, obviously because it's being dilated by a scale factor of a third, so it's shrinking. You can also notice that technically, since it's a line, they're the same exact line, so it still lies on PQ. So P prime Q prime still lies on that line PQ, okay? And then depending on whatever information is given in the problem, like if they tell you, oh, they're perpendicular, so there's a right angle there, then those lines are still, LM is still perpendicular to P prime Q prime, okay? So just make sure you read the question carefully. But if you guys have any questions, as always, you can go ahead and leave a comment below and I will definitely get to it as soon as I can. Thank you guys so much for all of your love and support. I truly, truly, truly appreciate it so much. From the bottom of my heart, it really means a lot to me. We work hard as teachers and, you know, it means a lot to know that my students are actually trying to get extra help and other students are trying to get extra help as well. So if you guys enjoyed this video, just go ahead and give me a huge thumbs up, like, so I can get some more exposure on YouTube and I can help more students like yourself. And don't forget to subscribe to my channel if you have not already. And I will see you guys in another video. Bye.